I think when it comes to chapter 2, you can read most of it on your own. So I'm not going to spend a lot of time explaining the details there, but I have a few sort of key observations that I would like to make. And one is one where you might say that the behavior of Maple is perhaps a little bit surprising, and so this is a very common source of errors. So let me just point this out so that you don't get this wrong. And this has to do, so I'm trying to show you two Maple worksheets side by side. So the point is the distinction between an expression and a function. And I think, as a mathematician, you're used to not distinguishing very much between these two things, because in a sense, if you have an expression, that's more or less the same as a function where you think of the variables as input to that function. But when you work in Maple, you really have to keep these two issues, two concepts apart. So, I mean, first let's look at the way that they're the same. So there's just slightly different syntax for how you do this, but suppose I have an expression a which is defined to be x squared, then I can plot a by saying plot a from x from 0 to 10, so that will plot all the squares with x between 0 and 10, so part of a parabola. And you can also differentiate this and get 2x as you would expect. And if you've taken Intro, you've probably seen this also discussed there. So you can also define a function f, which sends sends x to x squared. And you can see that the syntax is slightly different, but you can do it in the same way. You just say you want to plot f, and then you don't have to specify that it's x that goes from 0 to 10, because since f is a function of one variable, Maple can guess this on its own. And there's also an alternative way of differentiating, where you use a capital D, because this is a function of one variable, so it's somehow understood what you mean by differentiating f. So you don't have to specify that you're differentiating after x. But so the thing that you need to keep in mind, and which is the source of problems that I mentioned before, is that it's very easy to go from a function to an expression, but it's not so easy to go the opposite way. So how do I go from a function to an expression? Well, I just write f of x. So if I write f of x, then now Maple knows that I'm interested in the expression that defines the function f, and I could let this be a, and then I would work exactly like I'm doing on the other side of the screen. But you cannot do it in the same way. So if I was to use the syntax that I used to define the function over here with the expression, that's not going to work. So if I do, let's call it g, for instance, and sends x to a, so this is the definition I have, then you might sort of expect that what you're doing here is that I'm defining g to send x to x squared. But as you can see by looking at, for instance, g of 2 or g of pi or g of x, I get the same thing out. And this is because, what happens here is that when Maple sees this definition here, Maple will say, well, what I'm being asked to do is to define the function that sends x to a. And so that means that since a isn't explicitly dependent on x, then what Maple will say when I'm doing like g of 2 down here, for instance, well, Maple will say, well, x is defined as, g is defined as what sends x to a. So whatever x is, I will output a, and a, as I know from up here, is the same as x squared. Right? So I don't get the behavior that you would expect. So the way you need to do this, and this is not a very nice notation, but the way you need to do this is that you use the command called unapply. So unapply is to be thought of as the inverse of the application of a function to a variable that I used over here. So unapply, the syntax is like this. So unapply will take an expression depending on some variable, say x, and then it will make the function that sends x to the expression given by a in the way that you would expect. So, I mean, this is perhaps a little bit weird, but I mean, this is a constant source of confusion when you work with Maple, so that's why I'm pointing this out. Now, when we start programming in Maple, we're going to use a lot of procedures, and I want to emphasize the difference between local and global variables in a second. But let me just point out that in a sense, a procedure can be thought of as a generalization of a function, and it's actually a very wide generalization. So you need to be careful if you think of it as just being a function, that it doesn't really capture it. But the point is that I could create a function using the procedure syntax like this, right? So the syntax of a procedure is that I use this proc term, then I specify the input of the procedure, and then if the inside the procedure is some sort of return statement, then that's what's going to be spat out at the end of the when I'm running this. So if I say, for instance, square of pi, then I'll get pi square out, as you would expect. But of course, a procedure can be many more things than just something that takes something in and spits something out like you do in a mathematical function. A procedure could be something that prints out something, that stores something in a file, that reads a file, that gets input from the user, all kinds of things. And so a procedure is much more versatile than a mathematical function. Whereas, because a mathematical function has something that comes in and something that goes out. When you start writing programs for experiments, I would like you to consider making as many of your procedures as possible to be like a mathematical function. So it's a good way of organizing code, to have lots of small procedures that do just that one thing, where it sort of transforms some input into some output like a mathematical function would do. So I strongly recommend that you try to make all your procedures, well, actually not all of your procedures, but many of your procedures into a function like this. So that is the idea that I'm trying to suggest that you use here. So of course, when you have a procedure, so essentially also what's very nice about a procedure then is that you can use it and reuse it in different parts of your code. You're also going to have some code that you need to design in a way which does not fit the setup of a mathematical function. But most of the time, you would be able to put most of your code into procedures that are input-output procedures, and usually also very short, sort of one-purpose procedures. And then, of course, you can reuse these procedures into more complicated procedures, and that usually makes a nicer program. But of course, when you then try to apply mathematical concepts like differentiation to a procedure, that's not going to work if you have a procedure that does something more complicated. So actually, I'm just putting this in because I found it a little bit impressive that actually Maple realizes that the procedure that I defined is enough like a mathematical function that it can be differentiated into a procedure that outputs 2 times x. But of course, that is a bit of a novelty item. I don't really need that for anything. Right. So the procedure is a much more general thing than a mathematical function, but it's a good idea to keep your procedures as far as you can like the mathematical functions. Now, one thing where the procedures differ from mathematical functions is that they are allowed to change other things than what is precisely inside the function, and the most basic way this can happen is using a global variable. So let me explain what I mean by a global variable by first showing you a local variable. So when you have a, so I'm running this part over here, when you have a procedure which has a local variable, then that local variable will be changed inside the procedure, but as you leave the procedure, this is deleted again. Right? So what happens is I start with a variable called s. Then inside my procedure, I use a local variable called s. And then what I do now is that first I print what is s before I executed the procedure. It was set to 0 up here. Right? Then inside the procedure, it was set to 7. I get this out printed out here. But when I leave the procedure, s is restored to the original value. So this means that I have a local variable that sort of overshadows the global variable outside the procedure. So whenever I'm talking about s inside the local variable inside the procedure, it's the local variable that gets changed. Exactly like if you had a function that was defined, computed in some way, you wouldn't expect the variables that were used inside the function to matter outside the function, right? It doesn't matter if I define the function by sending x to x squared or y to y squared or, you know, Joe to Joe square or something like that. It's just a name that describes the function, and it shouldn't have any global consequences what you call it. But you can also work with global variables. And then you get this kind of behavior over here, which is a lot more like what you would expect with an expression. Right? I let s equal 0, and I explain that I want my s to be a global variable. Then when I run my procedure and I let s equal 7, that remains the case after I leave the procedure. Right? So I can change the global variable and do this sort of in all of my Maple worksheet this way. So the difference should be fairly clear. And also, if you don't specify what s is, then Maple is going to assume that it's local and give you a warning saying, I'm assuming this is a local variable. Why would you want a global variable? Well, it's a way of communicating from inside the procedure to outside the procedure. And this, in a sense, is a very dangerous thing. Right? You want your programs are easier to read and understand if you can sort of compartmentalize them into little procedures that sort of, like a mathematical function, take something in, spit something out. But very often we're going to need to get information out from procedures. For instance, if we have a procedure calling itself many times in a recursive setup that we will return to next week, then we need to somehow get the result of this big computation out, and then one efficient way of doing that is a global variable. You might also have a global variable to decide the behavior of a function so that you can sort of turn it on and off in an easy way, so that's convenient when you program. And finally, global variables are usually faster than local variables, so you also want to use them sometimes for efficiency purposes. But there's, of course, all kinds of confusions that can come with this. If I have many procedures that change s, then it can be complicated to sort of trace back why is s what it is and which instance of my procedure changed this and so on. So it will usually make less readable programs. So we will return to this, but I hope the distinction between these two concepts is sufficiently clear now.